Assalamualaikum warahmatullahi wabarakatuh. My name is SITI ROZILAH binti MUHAMAD RODZI. Today I will start this presentation for introduction. The aim of this project is to encourage students to apply their knowledge on structural mechanics and to solve the practical problem by designing model of a bridge and fostering effective communication between group members during their course of completing this given task. Modeling and simulation of the bridge performance can be carried out using available public domain software such as LIMPRO, where forces of the members and deflection of the structure can be analyzed. Bridge is a structure built in order to allow people or vehicles to cross a river or a valley and others. People and vehicles across natural and man-made obstacles can be carried by the bridge. In designing a bridge structure, it must be appropriate. Internal load, external load will be applied so that the bridge can be used safely by the user. For the model dimension, the overall length of the model is 10 meter. The clear span between edge of the supporting abutment must be 8 meter. Maximum overall width is 2 meter. Maximum overall height is 3 meter. Contact base area is 2 meter times 2 meter. The uniform distributed load is 2000 kilograms for overall length of the bridge. Size of I-beam for all members is universal column 305 times 305 times 283. This is for side view, this is for plan view, and this is for drawing for front view.
Hi, Assalamualaikum. My name is NABILA binti MISRAN and my matrix number is AA191475. And now I will show you guys about our teams make the design of bridge by using the LIMPRO application. First of all, we need to right click and choose join and put the join according to your design. For our project, we need to make sure the length of our bridge is 10 meters and their height is 3 meters. And then after that, we just after we put the join, all the join, we connect of each of the join by using the member. So make sure all the member is connect with each of the join. After all the bridge is complete by the members and join, we need to put the separation at here, which is pin support. And for our bridge model, we need to make sure the distance of between each support need to be 8 meters. So we put here another support, which is roller support. And then after that, we need to release of each member by right click and choose the moment release at the join 0. But we need to release all the members, and for the alternative, we use this to release them. So we choose all the members and release of the bending moment at all the joint. So okay, and then for the another member, we choose okay, and now we delete the orange line and the joint of red, and we need to change the red joint to orange joint by manually change the moment release. So this one. After that, we need to put the load for this part of members. So how to put the load? We just right click and then choose. We click here and choose the add load. For our project, we need to test this bridge by using the load of 2 tons, which is 2000 kilograms. But in this application, we need to change the unit to kilonewtons, which is 19.61 kilonewton. That's right. So we have fully completed our design model, and then we can look this view. And then to run this analysis, I click this moment, and then we can look your moment diagram like this. For the shear force diagram, the axial force diagram, this is for deflection line, and this is for draw reaction draw. So to get all of the input, output, and the result, we just need to print, save to PDF, okay, and print. So here is the result and data from the LIMPRO apps that we have designed for this, and I think that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is EZANI FIZAFARISHA binti KAMAL, and today I'm going to present about calculation for our bridge model. Okay, so as you can see, this is harshly our drawing for bridge. Okay, the length is 10, the height is 3, and it have a uniform load which is 2000 kilogram per meter. Okay, so for the it have two reaction, pin and roller at joint A and B. Okay, so for the reaction case, I use moments A equal to 0 and Fy force at y axis equal to 0. Okay, so after calculation, I get RBY equal to 98 kilonewton and RBY equal to 98 kilonewtons. And Fs is 0 because there's no other reaction as exists, so the reaction is 0. Okay, so this is for the internal force. Yes, for this calculation, I use joint calculations as it is more easier for me. Okay, so the UDL here is negative 19.61. Okay, so after I use it, and for CE, we have to include sine 19 as with Fy. Fy is we use sine, and Fx will use cos. Okay, so FCE is 22.64. FCE is negative 11.3.32. Okay, so tension, compression. Okay, and FAE and FAG. So I use the same method as the compression and tension. Okay, so it's all the same for the next. Okay, so the last one, we have to insert in table all the data that we get. Okay, so this is all the list of members beginning from CE to IB. Okay, there's a 0 first member here, and here. Okay, we have three 0 first member. So for a 0 first member, we don't have to include it in calculation. Okay, so we just have to find the parallel line. Okay, so that's all from me for calculation for our bridge. Thank you.
Hi and Assalamualaikum. My name is SYAZWANI NAJMA and I am from section 7. So for the recommendation, first we can use triangle shape as bridge design. By using triangle shape as bridge design, it will allow the load to be moving directly downward. Triangle bridges will distribute the load equally without it changing much their proportions, such as bending moments. So by using triangle shape as bridge design, the bridge will become stable and can take more load. Secondly, we can use suitable materials such as steel. Steel has a longer span as it has high quality material, strength quality, and also has a good durability. It also has higher tensile strength and high compressive. Nature of steel is lightweight and it will bring more advantages in long span bridges and also make the bridge can take more load. Thirdly, we can use reinforced concrete to cover the steel. The advantages of reinforced concrete are it has a high compressive strength, can endure a good amount of tensile stress, and also the resistance to fire and weather are quite fair. The reinforced concrete also will protect the steel from any corrosion. Fourth, make sure the forces are both in compression and tension equally. The compression and tension forces work together by compressing in areas and intensifying tension in other areas to make a bridge stronger and at the same time can take more load. Lastly, all the joints are fixed firmly. Each joint at the bridge should be fixed firmly and in a stable condition and sturdy to make the bridge can take more load. That's all from us. Thank you.